Greetings, Dr. Dan with Optimal Optics, here to introduce Unit 12P, word problems on the Gullstrand equations and cardinal points. I'm assuming you've already viewed the video on Unit 12. If not, this would be a superb time to do so. Question 1. What is the equivalent power of two thin lenses separated by 4 centimeters if the power of the first lens is plus 5 diopters and the power of the second lens is plus 8 diopters? Round your answer to the nearest tenth. So F1 equals plus 5, F2 equals plus 8, C equals D over N. The distance between the lenses is 4 centimeters. We have to convert that to 0.04 meters because the powers, F1 and F2, are equal to 1 over the focal length in meters. And the two lenses are separated by air with an index N of 1. This is Gullstrand's equation. And we plug in what we know. And we do the math, and we find that Fe equals plus 11.4 diopters. Question 2, calculate the back vertex power and the back focal length of a plus 8 diopter lens of index 1.5 with a front surface power of plus 12 diopters and a center thickness of 1 centimeter. Round your answer to the nearest tenth. So the power is equal to plus 8. That's actually the equivalent power. F1 is plus 12, and C equals D over N, and again, D must be in meters, so we convert 1 centimeter to 0.01 meters, and the index of the lens is 1.5. This is the formula for the back vertex power. We plug in what we know, and we find that the back vertex power of this lens equals plus 8.7 diopters. The back focal length is 1 over that, which will give us the answer in meters, which is 0.115 meters, which equals 11.5 centimeters. Question 3, calculate the locations of the principal points of a plus 8.3 diopter lens with a center thickness of 10 millimeters and an index of 1.5. The radii of curvature of the front and back surfaces are 41.7 millimeters and 125 millimeters respectively. Round your answers to the nearest 10th millimeter. That's not the nearest 10th M&M. We're not talking about candy. We are doing optics, nearest 10th millimeter. So we know that the power is plus 8.3 diopters. That means the focal length in millimeters is 1,000 over 8.3, which equals 120.5 millimeters. First radius is 41.7 millimeters. Second radius of curvature is 125 millimeters. The thickness of the lens is 10 millimeters, and the index of the lens is 1.5. So C equals D over N. We can keep D in millimeters this time, and the reason for that is the formula that I'm about to write down does not contain any units of power. All the variables are in millimeters. The focal length is in millimeters, the radius is in millimeters, and so D can stay in millimeters. So the formula is A1H equals minus CFN minus 1 over R2. That's the distance from the first surface, the vertex of the first surface, to the primary principal plane. And we'll fill in what we know. And we find that that distance equals negative 3.2 millimeters. That means that the primary principal point is to the left in a negative direction. A2H prime, the distance from the second surface's vertex to the secondary principal point, is minus CFN minus 1 over R1. Again, we'll plug in what we know. And we find that A2H prime equals negative 0.96. Rounding it to the nearest tenth, it's minus 1 millimeters. So let's draw it out and see what it looks like. This is a convex meniscus lens. Both radii of curvature are positive, going from left to right. And the thickness is 10 millimeters. The first vertex is A1, second vertex A2, and C1 and C2 are both to the right. So we can figure the primary principal plane is around there, 3.2 millimeters in front of the first surface, and the secondary principal point is very close to the first surface. Question 4, calculate the equivalent power of a thick lens whose front surface has a power of plus 25 diopters and whose second surface has a power of minus 5. The center thickness equals 9 millimeters and the index of refraction is 1.5. So we have F1 equals plus 25, F2 is minus 5, N is 1.5, D is 9 millimeters, and C is equal to D over N. So the Gullstrand equation is the equivalent power equals F1 plus F2 minus C F1 F2. So it equals 25 minus 5 minus 0.009 over 1.5. Again, remember that the powers that are written in this equation are equal to 1 over the focal length in meters. Therefore, the thickness of the lens must also be in meters so that all of the units will match. So we change 9 millimeters to 0.009 meters. And we find that the power equals 20 minus a negative 0.75, therefore the power equals plus 20.75 diopters.